So just plotted tangents and normals. I'll go through that later. Anyone got any questions about those? So that's useful because you can find the gradient at any point, so you can differentiate any curve provided you know the x-axis of the x value, and you can also get a sketch for what the tangent and normal is. Cool. Right, the other thing you can do is plot the inverse function. This is slightly less useful because it doesn't give you the equation, but it will give you the shape. So let's plot something a bit weird. So if we go back, what should we go for? Let's do e to the sine x. Let's see what that looks like. So shift e sine x. Again, yours will probably look better than this, but this is the old school notation. We are plotting trig. Oh, that looks right actually. So we plot that. So you should all know how to sketch inverses from your A1 or A2. How would you normally sketch an inverse? I can't even see you speaking. Yeah, what would you say?
You normally sketch the graph.
Yeah.
Over y equals x.
Yeah, reflect it in the line y equals x. So let's see if it will do that. So go sketch, in for inverse, and yeah, that's what it's done. So we've now got our sketch of the inverse of e to the sine x. So it doesn't tell you anything about it, and it can't, because if it did, it wouldn't be allowed in the exam. But it will give you the shape of an inverse. So say a question is sketch the inverse, you could sketch the rough shape of the graph, find its inverse, and it will show you what it looks like. Really good for remembering what arc sine, arc tan, and arc cos look like. Even I forget those sometimes. If you just want to sketch sine, and again, you might need to change this into, oh no, it looks right. So there's sine. If I forgot what arc sine looks like, I could just go sketch, inverse, and there's arc sine. And you can do the same for arc cos and arc tan as well. Cool. Any questions about that? So that's the sketch function for tangents, normals, and inverses. Cool. Right, the next useful thing that you can do on graphs is you can use graphs to solve equations. So let's say I wanted to, actually let's just sketch, if we go for, could you all try sketching x squared take 5? Again, adjust your axes so it looks kind of good, so I'm going to put some more minimum in there, so maybe -6. There you go, so something that looks a bit like that. Can you all try and sketch that with your adjusted view window? Okay, so this is one of the main functions on the calculator, is this G-solve button, which is F5. It stands for graphically solve, so if you click that, you get this new menu of things up. Most of these will be pretty self-explanatory. So root will find you the roots, so you could use that to solve a quadratic, solve a cubic, solve any equation, solve a trig function. So if I find the roots of this, we should get root 5 and minus root 5, which are these points here. So it finds you one root first, and then you can scroll over to find the other root. It won't give you those as exact values. So if the question wanted it as, in this case, square root of 5, you can only use it for checking, but it's useful so you can see where those roots are. Okay, we can also find maximums and minimums. So if I go back a step, draw it again, G-solve, I can find the, obviously there are no maximums for this one, so it would be pointless to do, but I could click minimum, and it will find me the coordinates of the minimum point. So again, you could use that. A really good application that would be in mechanics, where it says find the maximum speed. You can plot the speed and then solve to find the maximum, or any minimum maximum points in differentiation you could do as well. Okay, the other bits you got is Y-intercept. So obviously that's just going to find you, in this case that's the same as the maximum. It's kind of a boring graph, but again, YICEPT is the Y-intercept. And you've also got intersect. So if we go back a step, we're going to plot 2x as well. And draw that. Might try zooming out a little bit as well. So let's go we just do standard, it should make it minus 10 to 10, which is always quite a nice scale to have. So there we go. You can see the graph with the two intercepts. So if you guys could plot those two. What was the other function? So that's 2x and x squared minus 5. So Sarah wanted to solve when x squared equals 2x plus, wait, what was it? 5x? Whatever it was. I can then go gsolve and intersect, and it will find me the coordinates of the points where they meet. So if you guys try that, plot it, plot both, and see if you can find where the two curves meet. Okay, on the old calculators, that it would only find you stuff that was on the window. I think your calculators are a bit smarter than that, and it'll even solve stuff that's not on that visible window. But certainly for the old type, it'll only solve what it can see in front of it. So be careful with that. If you're ever trying to solve something, I'd make sure that you can see it before you try and use the solve function on the calculator. Okay, next up on this menu, there's a couple of examples that I have bothered doing. Could I get you guys to try and solve these two inequalities? So I'll give you a couple of minutes to try that. And I'll go through how I do it on the calculator. So two inequalities to solve. There's a couple ways you could do them, but we'll see what we come up with. Right, has anyone managed to do the first one? That fancies sharing what they did? Rob, are you done? No. Any ideas what you would do? Huh? Yeah, do you reckon you do it on this one? What can we plot then to try and solve this? Anybody? Yeah, so we're going to plot those as two separate curves and just look for when x squared is greater than the other one. So if I plot x squared first, and then plot 2x plus 7, draw those, we're going to try and find when it's greater than, so I'm going to find the intersects, which is here and here, and we want x squared to be greater. So it's going to be when x is less than that value, minus 1.8, because you can see the quadratic is above the line. And for the other value, that is when x will be greater than 3.82. So you could solve it by plotting two different graphs and just looking at when one is greater than the other. The other one then, if you plot this quadratic, x squared take 5x, take 7. X squared, take 5x, take 7, plot it. We want to find when this is less than 0, so we want all of these x values. So if I solve it to find the roots, x will just be between those two roots. So gsolve root, x will be greater than minus 1.14 and less than 6.14. Everyone right with that? So you can use this for inequalities. I do think the class whiz might be better at solving inequalities than this, just because it's quicker. You just type it in, hit equals, it gives you the signs and everything. But this is a useful way for solving other types of inequalities that you wouldn't be able to do on the class whiz. Right, there's a couple other bits on this gsolve menu. So if you go to the next page, we have xcal, ycal, and integral. If we go ycal, it will ask us for an x value. What this is basically doing is saying, if you give me an x value, I will tell you the corresponding y value. So say I want to find the y value when x is 2, type in 2, it'll find me that point on the x and tell me that y is minus 13. Or I could do it the other way around. I could go to gsolve xcal, type in a y value, so if y is 1, what is x? And we get x is minus 1.27 or 6.27. So that's really useful for solving trig. You could plot a trig graph, say when is sine 2x equal to 5, plot sine 2x, put in the y value is 5, and it will read off each of the corresponding x values. Okay, integral then. Cool. Integral is interesting. There's a few ways to use it. So it finds you the area under the curve. I think if we plot, what should we go for? Let's try plotting x squared plus 2. So if you go back up, delete the one we've done. X squared plus 2. Okay, so with the integration bits, it gives you a couple different options. If you go F5, which is gsolve again, navigate across the page and go to the integral dx sign. My calculator can be different to yours. It asks first of all for a lower limit. On yours you'll get a menu which will give you root, intersect or mixed. Root will obviously find you the area between your two roots. Intersect would find you the integral, the area between two intersections of two different curves. And mixed lets you put in your own limits. So if you guys choose mixed, and we'll choose the point, we'll go from 0 to 3. So I'm going to type in 0 and 3. If you guys choose mixed and then type in 0 and 3, it should do the same thing and sketch you the area it's going to find. Let me check on my other one. Sometimes it can be a bit picky about how it's doing it. I would say x squared plus 5 was it? Plus 3. Plus 2. Yeah, I mean, it's worth experimenting. The different integral options will do different things. Mixed is normally better, but of course, because this one doesn't have any roots, it's getting confused as to why there's no roots and you've chosen mixed. So the first button, the integral button, will just find you the integral between 2 points. If you type in your two values, it'll find you that integral. What can change is if we move that x squared down, we'll have a negative and a positive area. So let's try that. If we move our x squared to maybe x squared take 2 instead. And plot that. Now if we found the area between, let's say, 0 and 5. So we're mixing it up. We're mixing a positive area and a negative area. So gsolve integral 0 and 5. You can see I've got some area below and some area above. Now if you guys do that on the mixed option, it should give you not only the integral like you can see on mine, it should also give you a little green triangle with a different number. Can you all get that up on your screens? Let's check it works on mine as well. So, just working out on this one. What did I say between 0 and 5? Gsolve integral mixed 0, 5. Okay, yeah, so you've got the integral which gives you the same value as there. And then next to that you've got the little trapezium, little green trapezium that says 35.43. Any ideas what the trapezium is and why it's different to the integral? Dom, any ideas? Yeah, so the thing on the right is the area. The little green trapezium, that is the area. The thing on the left is the integral. So you know when we teach this, against first years this won't make any sense to you at all, but second years, the integral is literally what you'd kind of write down and solve. So the integral would be the positive area, take away the negative area. Whereas the little green trapezium gives you the actual area as if you'd taken both areas, made them both positive, and added it together. So that's really useful because it can show you if you've made a sign error, it will find you the actual area that's shaded rather than the whole minus sign, plus sign issue. So first is if you just write down on your notes, that little green triangle is quite important, or the trapezium is quite important because it gives you the true area, whereas the other bit just gives you the kind of standard integral. The difference between those will be more evident eventually, but that's kind of useful, and it'll only do that when you've got I think it's mixed, or roots will do that. The other options of integral won't give you that little green trapezium. Does that make sense to everybody? It's kind of confusing, but so that's why I'd always try and choose mixed if it will let you, because it will give you that actual area.
I can't get any over the green trapezium.
Let's have a look at that.
What did you choose for the Okay. You've got to choose mixed integral. Then you type push to close next. Now I want to do You guys all right with that? So area and integral is different. Yeah. You guys all right with that? Cool.
Okay, so yeah, bear that in mind when doing integration questions. That can be quite useful, and it will also integrate horrible things that you might need to use, I don't know, like by parts for. So if you try typing in x squared sine x, so x squared sine x. Lovely graph there. That would normally take you ages to integrate. The calculator will just do it for you and give you the answer. So you could check if you've done by parts wrong by seeing if your answer's the same. So if we integrate from, if we go from 0 to pi, there we go. It'll find you the integral there, and it'll also get you the area as well if it changed on your graph. Cool. Everyone right with that? Okay. It's always worth checking that the region you've selected is what you expect. So making sure that the region you've chosen is the actual region that the question's asked you to find. Okay, so that's all the graph skills. Has anybody got any questions about graphs or anything that you might want to do with graphs that I haven't shown you? No, everyone right with that? Cool. Okay, the other big thing the calculator can do then is solving any equation. And this is insane. When they showed me this, I thought it was amazing. So we're going to start off by solving some trig. We're going to do that with graphs, and then we're going to do it with algebra. So we're going to try and solve sine 2x is cos x between 0 and 360 degrees. So could you guys try this? I want you to plot sine of 2x, plot cos of x, make sure that you're in degrees, and then limit the window to 0 to 360 degrees, and see if you can solve it where those two graphs intersect to find those x values. First is, again, this will be quite new to you, but this is something we'll be doing after Christmas, so this will be useful. So plot two graphs, find where they intersect, hence solving that trig equation. And we could do it in radians, but this time we're going to do it in degrees. So if you guys give that a go, I'll do it on this calculator as well. If you've done it right, you should have a sketch a bit like that. I'm just going to change the y values to 1 and -1 so it looks a bit better. So that's the curve you're aiming to get if you've plotted it all correctly in degrees with the right limits and the right curves. Anyone need any help? You guys are right.
Why is that line really dark?
What do you mean, Frank?
It's not really fit like an X-axis.
The x-axis, probably just to show you that it's the axis rather than a random line. I don't think that's anything important. Louis, what are you stuck on? Setup error. Let me have a look. I haven't seen that before. Anybody else need help? Okay, so you're in radians. So in radians goes from pi is about 360 is totally 2. Anybody else? Okay, once you've got it plotted correctly, do you want to try and solve it to find where those two things meet each other? So if you go G-solve intersection, you can find where they meet. So G-solve intersect, and it'll find you the values of all these points in degrees. So you should get 30, 90, 150, 270. And you can scroll left to right to find all those intersections. Everybody wrote that? Yeah, so plot them, solve where they intersect, and you're essentially solving the two equations. And you could do that in radians or degrees, and you could do any kind of graph. You could solve exponentials, logarithms, sine, cos, tan, whatever you want. Plot it and then solve it. Okay, the other way to solve stuff that doesn't involve graphing anything is to go back to the standard calculator. So you could all navigate back to the run XE calculator. And this is the thing that really impressed me because I didn't know calculators could do this. So we're going to go to Option and then Calc. Go across the page and... Oh, I don't have it on this one. That's good. I'm checking the other place.
It's on the first place.
Yeah, this is a different calculator though. Okay, well, yours will have solve n written there, yeah? So Option, Calc, and then solve n, which might be on the second page. I think it is. Option, Calc, solve n. Okay, so solve n, Casio are a bit weird, and they don't like deleting things. So the old one was called solve, which you guys have as well. And then they updated that and called it solve new, which is solve n. So I don't know what the difference is, but solve n apparently is just better. So always use that one. If you guys choose it, I'm going to do it with solve, but I think it will be the same. So yours will say solve n bracket. And in this bracket, there's loads of different stuff that we can solve with the calculator. So we're going to start with solving some a nice basic equation. So the example I've got on the worksheet is 4x take 2 equals 7. So if you type that in, 4x, take 2, shift to get equals, and then 7.
Shift what?
Shift and full stop is the equals button. Okay, so it's a nice easy equation. You can probably solve it in your heads quite quickly and get 9/4. We need to tell the calculator what letter to solve for. So we're going to do a comma next. Comma is that button there next to the save button. Tell it x is the thing we want to solve it for. And then we could put in limits as well. We're not going to put in limits because there's only going to be one solution for this, but when we do trig later on, limits are quite useful. So close the brackets up. So we put the equation we want to solve and the letter that we want to find. And then going to hit xe, and it will solve it and give you the answer. Yours will probably do it as a fraction, but this is a bit older, only does decimals. Everybody managed to do that? Okay, so that was pretty basic. That was quite an easy thing to solve. It will solve anything you put in though. So the next one we're going to try is this exponential thing. So if you guys could type in e to the 2x is 15 and x, and we'll try that one. So solve e to the power 2x. Again, mine will look a bit different to yours because it's old. So e to the 2x equals 15. Put a comma, put the thing you're trying to solve for, so x, close the brackets, hit equals. What have we done? Can't solve. Oh, I forgot to put x in. Oops. And then it'll solve it. Okay, again, it might not solve it exactly, but again, you can use that to check any answers, and for trig it will. So next up, we're going to try and solve a trig equation. Without a calculator to solve trig, you have to draw a trig graph, solve it, find all the equivalent angles, stretch it, and then unstretch all your answers, so it's a load of work. Frank? You'd have to do most of it, but you could probably write, once you've got one answer, you could probably just write the others. So it would save you a bit of time. But the main thing is to check, because it's very easy to make mistakes on these questions. So if you guys could try and solve sine 2x equals cos x between 0 and pi. So this time we're going to put limits in as well. So solve sine 2x, so sine brackets 2x, shift equals, oops, I did pi, shift equals cos of x, comma, tell it x is the thing we want to solve for, and now we're going to put limits in as well. So 0 and pi, so put 0 in, put pi in, you just type them after the x. So the syntax, if you guys all know what the word syntax means? The the input style, I guess. You put the equation you want to solve, comma, the letter you want to find, comma, the lower limit, comma, the upper limit. Normally you won't need lower and upper limits, but with trig will go on forever, so you need to tell it where to stop. So, if you don't put limits, it will just solve it. And then it will give you all the solutions ever, and you'd have to know which ones to stop at. So, well, I think it will do like 10, and then it will say many more solutions exist. So, put limits in, it will tell you exactly what you find. So we're going to try 0 and pi as our limits. But yeah, make sure you're in radians, because otherwise you're telling it to solve it between 0 and 3 degrees, which won't work. So I'm going to change mine into radians now. Close brackets, hit solve. Yeah, mine doesn't work because it's the old type, but if you guys do it, you should get at least 4 solutions, which is pi by 6, half pi, and 5 pi by 6. Has everybody got that? So the old version only finds me 1 solution, yours will find all possible solutions. Ooh. Has everybody done that? Yeah, anyone need help? No? Cool. So that'll solve any equation that you put into it. Okay, last thing I'm going to show you guys today is the dynamic graph function, which is kind of semi-useful. If you forget how to do transformations, it's useful. Otherwise, you'll probably never need it. So I'll go through it quickly, and then it's there if you ever want it. Hopefully this calculator has it. Yeah, if you go to Dyna on the main menu. I don't know what that means. And just delete everything you've typed in so far. Alright, so let's say we've got something in front of us that we need to work out what a transformation is going to do, and that we've forgotten transformations. So we're going to try and plot x squared plus 5 plus x squared plus a. So if you do x squared plus and then alpha and a. So you get to there. You all should be aware that a is going to move it up or down depending on the sign of a, yeah? So we're translating it vertically. If you then hit execute, it'll bring up this menu here. And this lets us choose what values of a we can kind of go between. So I'm going to choose set, which lets me pick a range of values. So we're going to start a at 0 and move it up to 10. So it will show us the graph moving up from 0 to 10. And the step is how many animations it's going to go through. So if you do step 1, it's going to take 10 frames to get there. If you choose step 5, it'll take 2 frames to get there. I'm going to choose 5 because otherwise it really slows down the calculator. Yeah, okay. So how far have you got, Sam? So x squared plus a, hit execute, and then we're going to go set. Instead of 0, you just want to go straight to set. 0, so start at 0, end at 10, go up in 5s. And if you hit execute and dynamic, it will take a while. I'm stupidly zoomed out. So the annoying thing is this will use whatever settings you have of the last graph you plotted. So if it's not looking right, wait for it to finish doing what it's doing, or just mash the keypad. Go back to graph, plot any old graph. Yeah, you do have to wait a little while for it to chill out. So yeah, my view window is awful. If I go back to standard, there we go. Now go back to dynamic graph. X squared plus a. Okay, once you've got it all set up right, it should animate moving the graph up. So there we go, off it goes. So to get out of it, I normally hit menu, execute, delete, and on for a while, and eventually it decides to stop. I think delete might be the one. So if you push delete.
Do you shift AC?
Shift AC sometimes works unless you've made it do loads of animations, then it takes a while. It does take a while to kind of get back to normal though. So by doing that, you can work out what a transformation does if you've forgotten your basic transformations. Other than that, I don't think it's very useful. So that's only good as a last kind of ditch. I forgot what transformations are. Dan?
I think I've got it stuck in dynamic functions.
Yeah, it will get stuck for a while normally.
No, I put to a bad button.
So yeah, it might be useful. Not sure. I just want to show you guys it while we're here. Okay, so that's the last lot of new stuff. Before you go though, I'm going to make you solve 2 questions, actual exam questions, just using the calculator. So the first one is a second year trig R method modelling question, which most students find quite difficult. First years, this isn't something you'll have done yet, but you'll easily be able to understand how to do it on the calculator. So I'd like you guys to have a read through. It's on your paper in front of you. We're going to try and solve this. So we're modelling the height of a Ferris wheel with a horrible trig equation. Normally, you'd have to do a load of maths to that equation first to get it into a form you can understand. You then have to sketch that to work out the max minimum and where it all happens. With the calculator, you don't need to do any of that. You can just sketch the equation as it is, use the graph solve to find the maximum, find where the maximum is, find when it's 80 meters up, and find how long it takes to do 2 revolutions. So I'll give you guys 5 minutes to try and solve all of that question using the calculator. This will tie together everything we've done with the graphs so far today. And I'll show you guys how to do it because it is quite tricky, but you wouldn't get all the marks if you just did all of it on the calculator, but you can check every single bit of it. Rob, what's the problem? Are you in the right degrees radians thing? Is your view window set up accordingly? I think you want it to like 0 to 90 degrees for this one. So you want it in degrees because we're talking 30-degree angles. Have you not got a calculator? Yeah. It's fine. Yeah, use x instead of t and y instead of h. So I'll show you guys how to plot it and then you can do the rest yourselves. I would do like 0 to 90 and like 0 to 30 meters tall because you're not going to be going below the ground, you're going up. So yeah, 0 to 30 on the y and 0 to 30 on x would work. So maybe 0 to 60 on x. If you're stuck, just watch me and I'll do it now. So 12 take 10 cos 30 degrees, so 30 x plus 3 sine 30 x. See, I think that's kind of what you want to have on the screen in front of you. Roughly that kind of shape the curve. Anyone need any help getting to that stage? Yeah? Cool. Anybody else need help drawing the graph? Okay, 2 more minutes, guys, and then we'll try and go through it and have a look at how you do all this. Alright, so what the graph actually shows is someone's height when they're on a Ferris wheel. So you can see they start off on the ground, go up, come back down, go up, come back down as they're going around. So we want to find the maximum height that they get to. How could I find the maximum height then? G-solve max. Let's do that. G-solve max height. All the heights are the same. So the maximum height they get to is 22.4 meters. So we want the y value. The value of t when the maximum first occurs. How can we do that? Any ideas? Casper? Yeah, the x value at the first maximum, which is also already on the screen. So that's 5.4 minutes. We've got to the top of the Ferris wheel. How can I find the times where the person is 18 meters high for the first time? Solve y-cal and then type in, sorry, we want x because it's the x-axis. So x-cal and then type in 18. So solve x-cal, y is 18 meters up. And we get x is 3.6 minutes. And how can you work out the time taken for 2 revolutions? So if I exit that, draw it again. So, guys, quiet. 1 revolution will be down, up, down. Next revolution will be up and then down. So we want this point here, which is the second minimum. So if I do G-solve minimum, and I want to scroll along until I get to the second one, which is there, 23.44 minutes for that. So really quickly, I think that was 10 marks worth of calculations. You can check all those answers, and you've also then got a rough idea of, you know, what the graph actually looks like and what should be going on. Huh? You still have to do workings, but it's better than nothing. For some of this, I think you would, but definitely not all of it. You still have to do all the R method stuff, but for actually solving the equations, I think you'd be alright. I'll double check that though. Right, last thing I want you guys to try is this area integral. So I've done a sketch of an area integral. I've given you the b value of the shaded area. Could you guys try and find all of that shaded area using the calculators? Sam, you right? Yeah, sure. Huh? Yeah, it doesn't actually matter in this one. Anyone need help with this? Are you all right? Yep. Anybody else need help with this? So if you've done it right, your area should be 13.332. Yeah, everyone got that? Cool. Yeah, so that's pretty much it for today. Are there any questions or any other bits you guys want me to go over quickly? You're all right. Cool. I haven't done any statistics at all. Reason being, half of you haven't studied any statistics yet, and the other half of you still have a load of statistics left. So I think I might do a similar one of these just for statistics in March or April once you've all had it taught. But yeah, you're always welcome to email me if there's anything that you're stuck on or not sure how to do. But those guys should be pretty comprehensive anyway. Cheers, guys.